When we learned about classification of compounds or organic compounds rather, we studied about the fact that there are certain compounds which are cyclic in nature. So in this video we are going to be talking about how to name such compounds, and these are called as alicyclic compounds. So the first rule that we have is that the word cycle is used before the corresponding straight chain name. For example, this particular ring has 1, 2, 3 carbon atoms, and for such a compound, prop would be its basically basic word root. So here cyclopropane is the name of this compound. This would be cyclo 1, 2, 3, 4, so butane. This 1, 2, 3, 4 and 5, so cyclopentane. This has 6 carbon atoms, so cyclohexane. So we're just using the word cyclo in front of the straight chain alkane. Since they don't have double bonds, where I just said alkanes, so these compounds don't have a double bond. However, when we are talking about these, they have a double bond. Okay, this one also doesn't. So 1, 2, 3, 4, 5, 6, 7, 8. So cyclooctane. So in these compounds, it has a double bond. So instead of butane, we will refer to as butene. And so if this double bond was present here, it'll be cyclobutene. Even if it was present here, it's the same cyclobutene. So irrespective of the position, since there's only one double bond, we can just call it cyclobutene. And this will be cyclopentene. And this will be cyclohexene. So we are using the word ene, we're ending it with ene because it's an alkene, and this would be cyclooctene. So these, we just added the word cyclo before the straight chain name, and the reason we are not numbering the double bond is even if we say 1, 2, 3, 4, irrespective of where the double bond was, the first carbon, like the first position, we would consider it to have a double bond. So we just write cyclopentene, cyclohexene, and so on. Next, when we have a substituent, what do? So when you have substituent, we'll just be writing the substituent name as the prefix. So this will be methyl. That is the name of the substituent. Cyclohexene. This, on the other hand, is an ethyl group. So, okay, fine. That's an ethyl group. So its name would be ethyl cyclohexene. Hexane. I'm so sorry, this is also ane only because it does not have a double bond. So this is ethyl cyclohexane. On the other hand, this particular compound over here is a 5-membered ring. So it will be a cyclopentane ring. And since it has a chlorine group attached to it, it is chlorocyclohexane. Pentane, because it's a 5-membered ring. So we've learnt about just the ring, or there's just one substituent. We just write it as a prefix. Now, if we have another substituent in the mix, how do we name this? So when you have more than one substituent, their positions have to be indicated by numbers. So here you have two methyl groups. So let's say 1, 2, 3 and 4. Remember, in case of our straight chain alkanes, we use the word dimethyl, diethyl. So depending upon the number of groups, if there are 2 or more, then we call them dimethyl. So here in the first and the third position, we have 2 methyl groups, 1, 3 dimethyl. And since it's a cyclobutane, it's a square, so it has 4 carbon atoms, so it is cyclobutane. Next, in this case, we have 2 ways of numbering this. Now, here we will be numbering 1 and 2, because alphabetically speaking, ethyl gets number 1 and methyl gets number 2. So because it's in an alphabetical order, ethyl and then methyl. So 1 ethyl, 2 methyl, and it's a 5-membered ring which is a cycle, so cyclopentane. Here, however, you have methane, ethane, propane. So this is a propyl group and this is a methyl group. So N comes before P. So 1, 2 and 3. So 1 methyl, 3 propyl, cyclohexane. Next, you have another one which has more than one substituent. So here you have 2 methyl groups and here we have an ethyl group. But when we say dimethyl, that does not, because alphabetical order takes priority, 1, 2, 3. So the name of the compound would be 3, 3 dimethyl 1 oh, I'm so sorry. Even while we write the name, it has to be in the alphabetical order. So 1 ethyl, 3, 3 dimethyl cyclohexane. So that is if we have 2 or more than 2 substituents. In the next case of compounds, we have to figure out what the main number, which would be considered as the main chain. Now, in case of if the number of carbon in the ring is greater than or equal to the number of carbon in the substituent, then the ring is considered the main chain or the root. Whereas if the number of carbon atoms in the substituent is greater than that of the ring, then the substituent is basically considered the root. Now that does not make a lot of sense, but let's see this. So here we have a 5-membered ring and only 1 carbon. So the compound is a derivative of this ring. So basically this ring is present and this CH3 has been attached to it. However, here you have a 3-membered ring and then you have 1, 2, 3 and 4, a 4-membered substituent. So then this ring has been attached to the carbon of this ring has been attached to the carbon of the substituent. So this is considered the compound of the 4-membered carbon chain. Similarly, here you have a 5-membered chain and then 1, 2, 3, 4 and 5. Here you have equal number. So in that case, the main chain, this one, the substituent is like, okay, one second. Then this particular ring is the main chain and this particular thing has been attached to it. So your word root part of the whole name of the IUPAC name will be for the ring, whereas the substituent has been added. Now this also, it's the same case. So here it's a cyclopentane ring and you have a methyl group attached to it. So the name of the compound is methyl cyclopentane. pentane. Now, in this case, the number of carbon atoms in this substituent are more than the number of carbon atoms of the ring. So, you have 1, 2, 3, 4 group. So, in the first position, you have a cyclopropane ring. So, 1 cyclopropyl butane. Next, since there are equal number of carbon atoms, the ring will be considered as the main one, and then to it this chain has been added. So you have 1, 2, 3, 4 and 5 membered chain, which is a pentyl. So the name of the compound is pentyl cyclopentane. The last one, here you have methane. Okay, so here 1, 2, 3, 4, 5. You have a 5-membered chain, and then this is only 4-membered ring. So this becomes the main compound, and this is going to become the substituent. So 1, 2, 3, 4 and 5. So the third position, we have a cyclobutane added, and when it comes up as the substituent, it is going to be 3-cyclo butyl, and since it's a 5-membered chain, pentane. So we are just counting the number of carbon atoms. So there are only two possibilities. If the carbon of the ring, number of carbon atoms of the ring is greater than or equal to the number of carbon atoms in the substituent C of the sub, or the side chain, or the chain which is attached, then this will be the part of our word root. Whereas if it is the other way around, this part, the side chain will be the part of the word root, and that is what we observed in this and in this case. Here it is cyclobutyl pentane. So here it is cyclopropyl butane. So butane and pentane are the chains, right? The next one is if we have a functional group or a double bond, then the ring is treated as the substituent. So in this case and this case, both these cases, we have a double bond in this one and a functional group over here as a part of the side chain. So according to this rule, since the number of carbon atoms are less over here than the ring, this should be the part of the word root. But because it has a functional group, this will be considered a word root, and this and this are these two are the substituents. So let's number it. So our alkene is given more priority. So at the first position we have an alkene, it's a propene, right? And then at the third position we have a cyclopropane ring. So the name of the compound would be 3-cyclopropyl prop 1-ene. Next, in this case, you have an alcohol group. So 1, 2, 3 and 4. So at the third position, 3-cyclohexyl. We'll add the letters YL because it's the part of the prefix hexyl. 4 means 4 atoms of carbon, which is butane. So butan 2-ol, because it's an alcohol OL. So in this case, if you have a functional group or a double bond, then the side chain is considered to be the main chain and the ring is a substituent. And in the last two structures, you have more than one cyclic group which is attached to the chain. Then this compound is a derivative of the straight chain, which means this is technically supposed to be CH4, which is a methane, right? So 2 hydrogens of the methane have been replaced by 2 cyclopropyl rings. So irrespective of the length of the chain, even if it was like 10 carbon atoms long or 1 carbon atom long, if it has 2 cyclic groups, then the compound is a derivative of that straight chain only. So here you have dicyclopropyl propyl, and this is one carbon atom now, so methane. This is an A, this is not an E. Next, if you have, here you have 1, 2, 3, 4, 4 carbon atoms, and here there are 2 hexane groups. So, di, here however, 1, 2, 3 and 4. I think here we need to mention number, because here methane only has 1 carbon atoms, both groups are attached to the same carbon. But however, here you have like 4 different atoms. So 1, 4 dicyclohexyl butane. So first we started with just having the plain ring, and in that case we're just adding the word cyclo, and if it is an alkene we'll be adding the letters ene in the end. Then we have one substituent in each of them, and there we added the substituent as a prefix. If you have more than one substituent, they're ordered alphabetically, they're numbered alphabetically, and they're named also alphabetically only. And then here we started talking about the number of carbon atoms. If the number of carbon atoms of the ring is greater than or equal to the number of carbon atoms of the side chain or the straight chain, then the ring is the main part. So that will appear in the word root. If not, it's the other way around. Then next, even if we don't have more number of carbons in our substituent, if the substituent or the straight chain has a double bond or a functional group, then that is considered the part of the word root. And the last one, if for a straight chain we have 2 rings attached to it, then the straight chain, irrespective of how many carbon atoms it has, is considered that the compound is a derivative of the particular straight chain. So with that we don't finish the alicyclic compounds. There are a few more rules that need to be discussed, which will be done in the next video. Do check it out.